Hello, nice to see everybody. Yeah, LayerOne. So the next talk is by Zorro. It's Leeky Onions, de-anonymizing live Tor hidden services, which sounds awesome. So everybody enjoy, and please give it up for Zorro.
All right, can you hear me okay? No? How about now? How about now? How about now? Good? Yeah, whoa, there we go. Yeah, that's good. All right. So we're off to a better start this year. Last year, 2 laptops broke, and I had to borrow one to do my presentation. I couldn't see my own screen, so we're off to a good start so far. Before I get started, I just want to see show of hands who is familiar with the Tor network and who has never touched it before. So show of hands who's used it. Cool. All right, so I won't spend too much time, and this talk really isn't any kind of low-level talk about the routing protocols or anything like that. I'm going to just kind of recap on a very high-level overview of how it works and how the hidden services work as well from a routing standpoint. Everything is very high level, so if things seem oversimplified or even incorrect due to the simplification, I apologize. Yeah, so here we go. So a little bit about me. Well, what I'm not. I'm not a cryptographer, I'm not a developer, I'm not a lawyer, I'm not a professional. Who am I? I'm the guy on stage talking to you. That's all you need to know. Outline, what is Tor? How does it work? What are hidden services? How do they work? Some common ways that they could be misconfigured, and then we're going to go into some demos. I'll do it live if the demo gods grant me the ability to do so. All right, so what is Tor? Sorry to bore people who already know this. Tor is a network for anonymity. It uses multiple nodes in a network to route your data. It uses what's called onion routing to do that. I'll get into that in a little bit. The goal is to allow clients to remain anonymous to services that they're reaching to, whether that's inside of Tor or outside on the ClearNet. I'll try not to use buzzwords as much as possible. ClearNet's the only one I kind of can't get away from, but also, hidden services are now called onion services. I'm going to keep calling them hidden services. That was a decision by the Tor project because the media was making hidden services sound scary. But I keep calling them hidden services. And then lastly, there's also a goal to allow an endpoint to remain anonymous from a client, meaning that if you wanted to run a service, you could do so, and nobody theoretically would be able to know where that service is hosted. So Tor works with Tor circuits. A Tor circuit is basically a route that is built over the Tor network that allows you to connect to an endpoint or a hidden service. Each Tor circuit generally consists of 3 nodes. So what happens is when you fire up Tor and you want to make a connection to a hidden service or to a ClearNet address, you'll go and you'll pick 3 nodes on the network. I'm not going to get into detail about the different types of nodes and guard nodes and exit nodes, but there are 3 nodes that are selected. Generally, you can increase or decrease this count. Each one of these nodes has a public key. You end up doing a handshake with each one of these to get a session key, and that session key is what's used to encrypt the data. When they say onion routing, the reason it's called onion routing is because it's done in layers. So you take your initial TCP payload, and then you will take the key of the first hop, encrypt the payload, key of the second hop, encrypt that payload, third hop, encrypt that payload, and then you'll send it over the wire. And what will happen is, actually reverse that, I'm sorry, last hop first. What will happen is at each hop along the way, that node will remove that layer of encryption and route it to the next node in the circuit. The end result of doing it in that manner is when you send your initial data packet to that first hop there, the only node in all of these that can actually decrypt the data packet is going to be that first one because it was actually encrypted with its session key. It will remove that layer of encryption and forward it along to the second node. And again, now that's left is the encrypted data that was encrypted with the key from that second node, and so forth and so on, until it hits in this case, the exit node, where it goes out to the ClearNet. At that point, it's removed all layers of encryption from the Tor network and sent the packet out along the wire. It's important to note that this last hop in yellow or orange isn't necessarily always encrypted. It's up to you. That's where we're talking about using HTTPS or any kind of TLS connection or encryption. There are bunches of talks on manipulating that data flow from the exit node because you do get to see that data in plain text form if it is unencrypted, but this is not about that. So what are hidden services and how do hidden services work? So a hidden service is a TCP service. Unfortunately, right now, as it stands, the Tor network only can route TCP traffic due to some limitations of the infrastructure, or not the infrastructure, but the technology that's being used. But a hidden service will allow a host to expose a TCP service to the Tor network. It is only reachable over the Tor network. You cannot access that hidden service without having access to the Tor network. There are some sites for specifically HTTPS websites or HTTP websites where you can actually visit .onions without using Tor. You can go to any .onion and add a .to, and whoever owns, I guess, that TLD will go through and basically proxy that connection for you. So if you do want to take a quick look into Tor without actually connecting, you can use one of those many services out there. Again, that is just for web traffic. But generally speaking, you do need to be connected into the Tor network to connect to the hidden service. So let's talk very quickly about how the hidden services actually set themselves up and how they function. So when a hidden service starts up, it selects 3 relays from the network and it builds circuits to that relay. So again, the circuit is the 3-hop. It builds 3 different circuits and it takes those endpoint relays and it puts them in what's called a descriptor, basically a ticket. Inside of that descriptor says, these are the 3 endpoints, the 3 relays that I have circuits to right now. And if you would like to come talk to me, go talk to one of these relays. So it takes those 3 relays that it's chosen, it puts it in a descriptor, puts its public key in there, and then it signs that descriptor with the private key. Once it does that, it sends that data to the distributed hash table. The distributed hash table is a way that the onion addresses actually get advertised or answered when a client comes in and says, hey, how do I get to this onion? It does a query to the distributed hash table. The distributed hash table is a collection of Tor nodes that are trusted in a sense, and they basically will hold chunks of .onions descriptors. So when a client comes onto the network and it says, hey, how do I get to this hidden service? It's the job of this node on the distributed hash table to look up and respond to that. It's kind of your DNS of Tor. It's how those hidden services are resolved. So to kind of recap, the hidden service starts up, it selects 3 nodes, builds circuits to them, takes those 3 nodes, puts it in a descriptor, signs it, and puts that and publishes that to the distributed hash table so that people can come in and look up those 3 nodes, basically how to get to that hidden service. So when a client comes along and it wants to access that hidden service, it's kind of a dance that occurs, and it's a little tricky. I tried my best to illustrate without just ripping other people's graphics off here. So I'll kind of walk through it. What will happen is the client starts itself up, and it's got its connection already established to the Tor network. So it goes and it reaches out to the distributed hash table. We won't get into how that functions, but it reaches out to the distributed hash table and it says, hey, can I please have the record for abc.onion? In this case, let's pretend that this hidden service over there is abc.onion. That service has gone ahead and started up, and it's got its descriptor registered on the distributed hash table. So the client says, hey, can I have the descriptor for that? The distributed hash table says, sure, here's the hidden service descriptor. The client takes a look at the descriptor and it says, okay, this hidden service has chosen these 3 nodes that it's built these circuits out to. I can go talk to it on one of those nodes. So the client at that point goes and it builds a Tor circuit to that node, that introduction point. In this case, if we've got relay 1, 2, and 3 in our descriptor, the client needs to select any one of those relays to build a Tor circuit out to, and that's called the introduction point. So the client says, okay, I'm going to pick number 2, and I'm going to build a Tor circuit out to number 2. So it's building a Tor circuit out to number 2. The hidden service already has a Tor circuit built to number 2. Now, the hidden service keeps that Tor circuit established to that introduction point and just leaves that link open. And it then goes out on the network. That's where it gets a little complicated. It then goes out on the network, and picture that green line as this line right here. So that green line hasn't changed. The client then uses this red line, and it chooses a completely random node on the network to use as a rendezvous point. It then builds a circuit to that rendezvous point and holds that circuit open. So another circuit to a completely random node on the network that it holds open. After it's done that, it goes back to its previous circuit that it has to the introduction point, this green line here, and it says to the hidden service, who's listening on that yellow line, it's built its circuit out, it says, hey, I would really like to talk to you. Can you come over to this rendezvous point and we'll talk over there? And at that point, the hidden service goes and it builds its Tor circuit to the rendezvous point. So now you've got the client and the server both connecting to this randomly selected rendezvous point, at which point they can go ahead and send pictures of cats, because that's what you do. So what are some attacks on hidden services? Well, real quick, does anyone have any questions about that routing? I know it's kind of a convoluted dance. No? All right. So attacks, there are a lot of attacks on hidden services. A lot of the attacks on hidden services have to do with the routing, not so much what we're going to talk about today. I wanted to be able to come up on stage and show some techniques that I wouldn't get arrested for, so we're not going to do that. But some of those attacks are things like timing attacks. So if you are, let's say, big government and you have visibility into the backbone of networks or uplinks to ISPs, you can watch traffic correlation and you can say, hey, when this user connects into Tor and they send 3 packets goes to this hidden service over here, and they can just kind of watch these different points along the network, and they can do timing correlations. One of the other attacks is forced paths. So if you have a bunch of rogue nodes on the network that you want someone to come onto and you want to analyze that traffic, you can do denial of service attacks on other nodes on the network and kind of force people into your nodes. Service exploitation is one of the main ones. Just like the internet, these are regular services. A lot of them are vulnerable. You find a lot of IRC and web servers mostly on Tor. A lot of the web servers are poorly coded PHP code. A lot of the IRC servers run really bad botnets, command injection all around. And then OPSEC, so slip-ups on the administrators. We've seen this with Silk Road. We've seen this with quite a few folks that have tried to run hidden services. Then you've got ODAs as well. Sorry, that kind of goes back up to the service exploitation. The ODAs can affect either the services or the clients. We've seen in the past federal agencies use JavaScript ODA to actually break out of client browsers so they could de-anonymize clients who went to these hidden services. So there's a handful of attacks against hidden services. But today we're just going to focus on the misconfiguration aspect where an administrator has kind of slipped up. So how do you interface with Tor if you want to play around with this stuff? Most end users will use the Tor browser to connect into Tor. It's probably your safest bet if you're just going to browse the web. They've got a bunch of cool features in there for you to try to help these de-anonymization attacks and fingerprint attacks. A lot of services, all services that showed up will just use the Tor daemon directly, and I'll talk about what that looks like in a minute. Tor is exposed to the client in the form of a SOCKS proxy. So when you actually start the Tor daemon, you have this SOCKS listener that's just sitting on localhost. Anything that speaks SOCKS can be configured to use that SOCKS proxy. And you can also use a series of tools like proxy chains. There's Tor-specific ones like Tor SOCKS and Tor-Fi that will actually hook that application on launch, and it does something similar. It may even do LD preload, where it actually hooks all the network calls, so it forces everything, it wraps it, and then pushes it through that SOCKS proxy for you. Again, we're talking TCP only. There is some DNS resolution that can occur, but we won't get into that. So servers, if they want to expose a service, they can modify their Tor configuration file so that when Tor starts up, it will actually map a hidden service to an internal service that they're running. So there's a few ways, as I mentioned previously, to interface with the Tor listener. The Tor SOCKS proxy fires up on localhost only so that you can't access it from your public interface. So if you wanted to start Tor, you can install it through the package repository. You can download it, check the checksum, and do the installation. But once it's installed and once it's running, you basically have a SOCKS proxy. To interact with that SOCKS proxy, you can use a variety of tools that I mentioned earlier. This is the demo here of just how quick and easy it is to use these tools. Here's a simple curl, just going to this website that returns your IP. In that case, we can see the IP of my VPS. This is the VPS I spun up for testing. The next one, we're using Tor-Fi with curl. So you just put Tor-Fi at the beginning of your command, and you run that same exact curl command, and you'll see that we're actually getting the IP of an exit node. And the same thing will happen with Tor SOCKS and with proxy chains. You automatically get routed out to that exit node in your circuit. As far as why these IPs are the same, you'll notice I've got the ClearNet IP on the first request, and then the next 3 requests all come out from the same exit node. Your Tor circuits have a lifetime on them. The last 2 hops in your Tor circuit will change over a period of time. So after, I think it's a matter of hours, it will actually rotate those circuits. You can build new circuits whenever you want. So if you wanted to, you can actually ask the Tor network, hey, please initiate a new circuit, and you get a different exit node. So if you're trying to change your external IP and you want to change that dynamically, you can actually issue commands to do that, and it will update your, it will build a new Tor circuit for you on the fly. The first hop, the entry node, that actually stays the same for a few months. That doesn't change. The first of the 3 nodes stays the same. The reason is, if that was changing constantly, there's a higher probability that somebody could come in and de-anonymize you just because of the frequency of that change. So the idea from the Tor project is, if the first hop doesn't change for a few months, you're either fucked right at the beginning, or you're not fucked for 3 months. So setting up a hidden service, very straightforward. In this case, I'm doing this on Ubuntu 16.04. I just went ahead and I added the repository for the Tor project into my Debian install. I installed that, and I installed Apache. We'll say we're going to expose Apache as our hidden service in this case. Once Apache was installed, I went ahead and I modified the Tor configuration. You can see all that really needs to happen is the Tor RC will have to be updated so that it exposes the Apache interface. It's as simple as going into your Tor RC configuration saying, hey, I want Tor to listen on this port, let's say 555, and whenever traffic comes into my hidden service on 555, I want it redirected to this port, 2280, whatever you want. So you modify the Tor RC, you restart your services or start your services, I typoed there. And then lastly, you need to know your hidden service name. Your hidden service name is actually stored in the varlib Tor hidden service directory, at least on Debian and Ubuntu based distros. You can just cat it. That name gets generated as soon as you enable the hidden service in the Tor RC. There is a corresponding private key. That hidden service name is basically a hash of your public key. The public key is derived from that. You use your private key to do some of the cryptography involved. So for this attack, I wanted to go through, or for these attacks, I wanted to go through and look at some onions and see if there were misconfigurations that I could find that would allow me to get their ClearNet IP addresses or any other information that would de-anonymize them. To do that, you need to have a list of onions. To get onions, there's a few different ways. A common way or a common approach to obtain onions is to actually become a node on that distributed hash table. So you get onto Tor and you sit on Tor for a while, and Tor begins to trust you. And then you can say, hey, I'd like to be on the distributed hash table. They say, hey, you check out, let's go ahead and get you on there. And once you're on the Tor network or on the Tor distributed hash table, you'll actually start to see hidden services start up and register with you like a DNS server. They'll say, hey, here's my descriptor. And since you're just sitting on since you're sitting on the distributed hash table, you can just gather those descriptors, and all of a sudden you get this list of onions that are there. The other nice thing is, if you're sitting on the distributed hash table, you get to see the requests coming in for those onion sites as well. So you can kind of do analytics on how many requests came in for different sites, and then you can say, what kind of content was on each site, and infer kind of how many people were doing what. Was it botnets? Is it web traffic? There are a lot of threat intel companies that do this now. If you see a lot of people out there that offer darknet scans and monitoring, a lot of times they're actually sitting on this distributed hash table collecting these onions. And as soon as they see one register or one get requested, they'll go ahead and start scanning that hidden service and looking for information on that hidden service. There is a change that just came out a few months back to the Tor hidden services. They're calling them next generation hidden services. And again, not being a cryptographer, I can't tell you the magic sauce here, but a key is used that's derived from the actual public key. So now in the future, this is just starting to roll out. You will no longer be able to sit on the distributed hash table and get the direct hidden service address. Again, can't tell you how that works, but that is something that's coming up. However, the older version, the older technology will be around for quite some time, so this will still be a possibility for a while. I, on the other hand, just used ClearNet, so I went to Pastebin and got an initial list of hidden services. I think I maybe walked away with 4,000 of them, and then I went through and I built a recursive scraper that just hit each one on a web-based port and then scraped any onions I found, so I just built out a list and kind of deduped that over and over. I think in the end I was left with maybe 5,000, 6,000 nodes for testing. Not all of them were online, obviously. Tor hidden services are very volatile. They go down often. There was a guy who spoke at a B-Sides, I forget where, I think his name was Dr. Gareth Owen, and they have a really good talk on this whole sitting on the distributed hash table and looking at these registrations and requests. I question the ethics and the legalities of doing so, but they don't seem to have an issue with it. They did it, and they have some really cool data. I definitely recommend watching the talk. They go through and they talk about a variety of things, but one of the more interesting things for me was they're sitting on the distributed hash table and looking at these onions, and then they produced a set of analytics. I believe you can actually obtain the data set and go through it as well, but he was able to give you a good breakdown of what hidden services are out there and what content they're serving up. All right, so getting into the actual common misconfigurations that we're going to look at, it's really easy to expose this stuff if you haven't properly configured your service or if you don't really know what you're doing. A lot of times you follow these guides that you're following for ClearNet sites, and if you're not familiar with the underlying technology, it's really easy to expose de-anonymizing information. There are a lot of tools that exist for doing these things. When I first started, I just started doing this because of a very specific de-anonymization vector. And then I started thinking about other ones, and by the time I was done, I realized that somebody had already built this tool, of course. So there's a tool out there called Onion Scan, which does a lot of what I'm talking about today. I think there's only one technique I'm going to cover that I believe no one else is doing currently. I may be mistaken, but definitely check out Onion Scan. I have code that I wrote. It's a horrible, shitty bash script, so I'm not even going to show you the code, and I probably won't release it because it's garbage. Definitely look at Onion Scan. You don't want my code. All right, so the following examples are only some of the ways. There's quite a few more ways. Obviously, I couldn't cover them all, but I wanted to cover some of the more fruitful and easy ways to look at this stuff. So the first one, and the most well-known, is the Apache server status. Apache server status is a module that can be enabled on Apache. I'm not sure who here does Apache administration, but the idea is, as an administrator, you can actually go to /server status, and you can see stats about hits that have come into your site for requests. You can see system load. You can see a variety of things. Normally, this module isn't enabled. Generally, this is something that needs to be enabled. And when you do enable this, it's usually good practice to only expose this module to localhost. So most of the time you'll see if people do enable the server status module, the ability to go into the URI and do /server status and view that information, they'll only do it on localhost. And the reason is if you're an administrator, theoretically the only person who should be viewing that from localhost is you. So you've kind of some kind of a protection mechanism there is to hide it in the localhost binding and not expose it to the internet. There's an issue with that, and the issue is when you configure your Tor RC, you're actually exposing localhost bindings, generally speaking. So it would be silly to run a Tor service and expose that to the internet. So you only bind it to localhost. And then when Tor SOCKS proxy is running and you go into your Tor RC and you say, I want to expose this service, you expose the localhost service. You don't expose one exposed to the internet. That would be silly. So looking at this configuration here, the second echo hidden service 80, that's basically all I'm adding there, and I'm just saying expose 127.0.0.1 port 80 to port 80 on Tor. So again, it's my local host binding. So getting back to the server status page, the issue with that is when you expose that to local host, you're actually exposing that to your Tor binding. So that's all well and good, but it's not that common. Unfortunately, most people are using Ubuntu or Debian, and most people are using Apache. The issue here is that the default package that's maintained by Ubuntu enables server status by default and only puts it on localhost. So they try to do you a favor and only enable it on localhost, but by doing so, the default package that you find for Ubuntu, one of the most commonly used VPS servers that people are going to utilize, and Apache, one of the most common web servers, you're instantly shooting yourself in the foot because you've exposed this server status page to everybody on Tor. And we'll get into exactly what that means aside from just the de-anonymization factor. So this is an example page. All of the hidden services here are real. I don't know how legit these hidden services are, but they are all ones that I found when scanning. I did try to make sure that most of these are just carding or forms, nothing horrendous that can be out there on Tor. So this site here, it looks like there was actually, I found this out through the hidden the server status page. This guy's running 2 or 3 different services on different onions. On the left, he's got this thing called cool name OK, where he's actually brute forcing the hidden service names. You basically generate a bunch of keys, and we'll take a look and say, oh, I want a key. There's thing it's called Vanity Onion, where you go in and you say, I want a hidden service name that has this in it, and you can only usually do up to about 8 characters, depends upon your resources, but it will go ahead and generate a crap ton of hashes and look for one that matches, and then you get that key pair to use for your hidden service. So you can basically brute force these vanity domains. So he's selling these vanity domains on one page. On the other page, there's a paste bin with who knows what. That is another service. Actually, this one on the right, sorry, there's an ad for the paste bin. The one on the right, I don't know what's going on there. So this is the server status page for that hidden service. This hidden service is up currently. If you go to /server status, as you can see in the URI, barely. You can see that I'm able to view all of the requests that are being made to this server, both on the public, the ClearNet address, and the internal address, because it's the same Apache instance. So a few things here. One is, instantly, you can see there's a request made to this FQDN, its actual external domain. That's going to be the de-anonymization vector there. But it's also important to keep in mind that I'm seeing the full GET request here. And for a lot of people who do any kind of web dev, you know it's important to put any kind of sensitive data in your post request because you don't want it to be visible. Well, you do get a lot of that information that gets sent in your GET request. And you also get session information. So sometimes you'll see session tokens or IDs, and you can actually go ahead and just rip these out, copy them into your browser, and hijack someone's session just because you're able to see that data in the log. So in this case, looking at the hidden service, looking at the FQDN, we can go ahead and just make sure that's a legit name. Sometimes people just make up names like notfound.com or itsnothere.org. But in this case, this one does indeed register or resolve to an actual IP address. So to recap, all we did was we found a hidden service. We just did /server status. We looked at there was a request for FQDNs, made sure that FQDN was legit, and now we've fully de-anonymized that hidden service. All right, so the next vector is missing host headers. This vector, I don't think anyone else is doing currently. I found this on accident. OnionScan is doing something similar, which I'll talk about at the end here, but I don't believe they're doing this yet. So there's an issue where if you host a website on the ClearNet and you host a website on Tor on the same Apache installation like we just saw, you're running the same configurations from that Apache instance. When an Apache server is configured for multiple vhosts, it's all done in a set of configuration files. When Apache gets a GET request for a vhost and there's actually no host header in the request, it will default to a default configuration. And that's the attack vector here, and I'll dive into that a little bit because I know it sounds kind of cryptic. So here's an example configuration. I spun up an Apache instance on my VPS, and I created 2 sites, one on the ClearNet and one on my hidden service. As you can see, they're both bound to port 80. Each one of them has a respectful server name. The server name should be what directs the incoming connection to either var www HTML or hidden service, and I have different content in each folder. So I've got these 2 vhosts configured in this single configuration file, and it works. So if you go to my ClearNet site, you get this cool picture of this cat with 2 different eyes. If you go to the scary hidden service site, you get this awesome hacker kitty. So from the Apache docs, there's an interesting bit that says, and this is ripped out of where they have a demo configuration, so it's hard to see, but pretend they're talking about the configuration I just showed you. Due to the fact that the virtual host with server name example.com is the first in the configuration file, keep in mind my ClearNet was the first in configuration file, it has the highest priority and can be seen as the default or primary server. That means if a request is received that does not match one of the specified server name directives, it will default to that first entry. So if you make a request and you don't specify a host header, it will default to the first entry in the configuration file. So I'm going to go through why this is bad, and I'll do it step by step. In this first command, I'm doing a curl to the hidden service, and I'm specifying a HTTP method that doesn't exist, which is called garbage, as you can see with the -x. And then next, I'm specifying a host header of my hidden service. So I'm making a request to my hidden service, and I'm specifying my host header of the hidden service. But I'm using an HTTP method that doesn't exist because I want it to error out because I want this specific response. So it errors out, and it says, I don't know what the hell you're trying to say. The server located at Ubuntu at this hidden service address on port 80 doesn't know what the hell you want. All right, that's fine. So now if I make the same request to that hidden service using curl, using garbage as a method that doesn't exist, but I don't specify a host header, I leave that blank, and I make the same request to the hidden service, what's going to happen is that hidden service is going to receive the request. It's going to go to the Apache server. Apache server is going to say which vhost does this go to and look for that host header, but the host header is missing, so it doesn't actually know where it goes. So per the docs, it chooses the first configuration, which means as a response in our error message, we're actually going to see the server name from that first configuration. So if we go back to this, you'll see the server name directive that's configured, and you'll see in the response when I have no host header that I'm making my request to the hidden service with no host header, and I'm getting back the configuration for the ClearNet IP address. This works a lot. It's kind of crazy right now how many web services on Tor you can hit, and you'll get this ClearNet information back. Sometimes you'll get the FQDN, sometimes it'll be the IP. Other times it'll just be another Onion service. Depends on how they have it configured and what they're running. So let's get into a demo of a live hidden service for this. This here is a website, home hosting, be your own VPS. This guy says that he'll set up a virtual private server for you. You can just go to him, totally legit, and he'll set all this up. I'm going to go ahead and do the same things I did previously to this host, and we'll see if we can de-anonymize it. But before I go, I just want to take a minute to take this. Look at this guy. Look at this picture. That's amazing. Look at that. Yeah. Look at that. You'll see I'm not going to plant the back door on your operating system. I think the best quote from that website is, "A well-crafted Linux system is a very stable system and will continue to work long after I'm gone." All right, so in this case, I'm using netcat. I probably should have stuck to the same commands with curl just to keep things simple. But anyways, I made a request on port 80. I sent it the garbage method, not even really. I just netcatted it, and I could have typed anything and hit enter twice. So it errors out, doesn't know the method, comes back, and it gives me this URI, or this domain of pown.hu. So same thing that's happened here. This guy must be running both a ClearNet site and a hidden service site, and the fact that I didn't supply a host header defaulted to the default configuration and returned to me the fully qualified domain name of the public site. So if we go and we verify, again, that this public site is legitimate, again, a lot of times people will put silly things in here like does not exist or notyourvps.com, and you always want to go ahead and verify. A lot of my findings were false positives, and verification is key of this stuff. So here it is. Here's Pwn, pwn.hu, Pwn, power of the internet. Not 2016 anymore. I don't know why that's there, but you can see that there is a live DNS entry for it, and it registers back to this IP address. So earlier I mentioned that Onion Scan does something quasi-similar to this attack. Onion Scan does host header manipulation, but the host header manipulation that Onion Scan does is it will attempt to get another configuration if you assume that website is running. So if you have a hunch that this hidden service is also running apple.com, you can actually go into that host header and put apple.com and see if the apple.com configuration is returned to you. So they're doing manipulation where they're trying to guess the configurations that might also exist for different hosts, and they're making the requests in that host header for those other sites to try to prove that site is co-hosting apple.com in this hidden service. You can also use that as a verification technique. So in this case, where we assume that pwn.hu is indeed this same host that's running this super awesome VPS service, we can verify that by modifying our host header to our hidden service and make it pwn.hu. So in this case, if we go ahead and we do curl garbage method, we give it the host header of the hidden service. I'm sorry, let's do this reverse. We're going to do it to the ClearNet site. We give it the host header of the hidden service, and we make our request to the ClearNet. So again, this is not on Tor. This is just on the regular internet. You go and you make a GET request, and for your host header, you specify that hidden service name that you know is being hosted there. It will actually respond back with the fact that there is a configuration file for that hidden service. So now we've been able to verify 100% that this hidden service is running on this machine. All right, so the next one is SSH key fingerprint lookups. So a lot of times when administrators set up a hidden service, they want to be able to access that hidden service, sometimes on Tor, sometimes without Tor. Sometimes Tor can be so slow you just don't want to deal with it. It's gotten a lot better. But because of that, they will expose SSH to both their hidden service, or the Tor network, and to the ClearNet network. When they do this, a lot of times they don't realize that there's static information that can identify that connection. So in this case, we're going to be looking at the fingerprint of the SSH public key that is served up to you when you initiate your connection to that server. So when you fire up any SSH connection, first thing you're going to do is get that pub key. You're going to get a fingerprint of that key, and if that same key is used for both sessions, both configurations, the daemon listening on Tor and the daemon listening on the ClearNet, the key is going to be the same, the fingerprint. So we can use tools like Shodan, Census, Zoomeye, and we can actually identify ClearNet IP addresses that are using that same key, or domains that are using that same key, same fingerprint of that key. So here's a demo of this attack. This site is a site where you can apparently buy things, identity documents mostly, bank statements, falsified information. And then in this case, we're going to see if SSH is listening. We're just going to go ahead and specify that we want the MD5 fingerprint. We make our connection, and that gets advertised to us. We extract the MD5 fingerprint, and we go and we plug that into Shodan. We plug it into Shodan, and we see that this host is actually using that same fingerprint. Oh boy. Come on. Son of a bitch. All right. So in this case, Shodan has come back and said, "Yeah, this guy over here is running the same. He's using the same fingerprint, and we're able to identify the fact that most likely this server is the same that's running the SSH instance with that private key." I did find one host in my scans. I haven't dug into it yet, but there's a host on Shodan that has the, sorry, not private key, public key. There's a host on Shodan that has the public key fingerprint for every server I found on Tor that has SSH running. I don't know what they're doing, but for the most part, when I query Shodan with any of these keys, this other server comes up with this data set that has the information in it. I haven't even looked to see, is this a web service that's serving this content up, but someone's tracking this stuff as well. All right, so the next one isn't a direct de-anonymization. Earlier I said that you spin up a hidden service and you use a private key and a public key to basically prove ownership of that hidden service and to do cryptographic signatures and communications. A lot of people don't understand the sensitivity of the private key. You have a lot of people who just want to set up a hidden service. They probably should have gone to the doctor guy, but they didn't. So instead, they set this up and they say, I'm going to put everything in this one directory because it's really easy for me. So all my Tor stuff is right here. My web server stuff, my Tor configuration, my keys are here. Everything's here. So I can just zip it up, move it around. And again, if you're not familiar with what you're doing, that can cause you to actually leak that private key. So the lady who runs Onion Scan tweeted out a while ago, yeah, this is actually a thing. It's kind of crazy. And I looked, and just in someone's root web directory was private underscore key, like the private key served up from the root directory. And I thought, that can't be a thing. So I went over to my computer, I plugged it into my scanner, ran the scan, went to sleep, woke up, and had, I think, 26 private keys. Now, here's a demo of the private key leakage. This is a website. It looks like it's somewhat dated. People haven't responded in some time, but it looks like it was a forum mostly, maybe card. There's advertisements for cards. Obviously, the classic how to hack Facebook. But anyways, if you just go into the URI and you add a / private underscore key, you'll see that the private key instantly comes back. In this case, I've just done it through curl. And with this private key, I can now spin up as this hidden service. So I can start my own hidden service as the identity of this hidden service. Now, again, this doesn't directly de-anonymize the hidden service, but this will allow me to do a variety of things which are out of the scope of this talk. I can clone their site. So the admin comes in, he logs in, and I get his creds. I can inject malicious JavaScript into any of the viewers who go to this site. So through this vector, there is a variety of ways which you can de-anonymize not only the hidden service, but the administrator and the users as well. Yeah?
Is there
Yeah, so I definitely never would have done that, so I don't know. I'm sure you could find out very easily. Admins troll, which is fun. The admins who actually know what the hell they're doing will troll the shit out of you when you're doing these things. This person has horrible English, but they did make me laugh. And it doesn't stop. This is a good one too. This is probably my favorite. And then lastly, this one. This one kind of tricked me up because he put, right? Yeah, I looked at it, I was like, score, oh, shit. All right, and then I think the last one I'm going to talk about today before I go into some demos is verbose and misconfigured web services. So many web applications can leak information just by their configurations. One time I found an OwnCloud instance. Somebody had set up OwnCloud, and I've seen this with Plex as well. They set it up on the ClearNet site, and then they converted it over to a hidden service. But a lot of the ClearNet domain information or IPs were hard-coded into some resources, whether it was a JPEG that was used or a link that was used. So scraping a site can actually reveal ClearNet IPs or domains as well. You can also find this in the form of info.php, or if debugging is enabled on like Doku wikis, you can get a lot of this information from verbose server configurations. I didn't think to scan for info.php until yesterday, so I went through and scanned. I found a decent amount. Most of them were internal IPs, so it didn't really help me out. I did find this one really quick one that does list its public IP inside of the info.php. Sadly, by the time the next day when I went to go hit it, I got a 500 error on the server, so I wasn't able to take any pretty screenshots. But just again, keep in mind setting up a service initially on a ClearNet site, converting it over, or exposing these debugging interfaces or verbose debugging information can de-anonymize that. Other common checks. Service banners, and again, OnionScan does most of this stuff. I'm not advocating for OnionScan. I've actually never used it, but I know it will do service banner checks as well. I think it probably checksums the server banner and then goes elsewhere and looks for the same information. Obviously, HTTPS certs can have the same effect as the SSH public keys fingerprints did. DNS lookups. It's a little tricky with DNS because of caching servers and how DNS is going to be routed, but there are ways in some situations where if you control a name server, you can get a hidden service to do a lookup directly to you, not through Tor. Exploitation, again, really bad PHP code out there, so just a command injection or SQLi away from hopping on the box and enumerating it that way. And then there's many more. So let's do some demos. I'm going to try this live. I recorded it just in case, so let's see what happens. I will zoom in a sec. Oh yeah, I lost my SSH connection. All right, so all right, you guys can see that. All right. So I'm just going to run my horribly written script here called scan'em, and I'm going to supply it a list of onion addresses. So the onion address list is just that, just onion addresses. For the sake of demo, I went ahead and just grabbed some of the more interesting ones to trim it down. When I run this over thousands, I just run it at night and go to bed. Sometimes, since I'm not a developer and I'm not cool enough to do multi-threading, sometimes I'll open like 20 screen sessions and chunk up the file and do it that way. So I'm going to go ahead and just let this run through. It will take about 4 minutes to do so. So as this is running, and also if we get bored, I can kill it. I have a backup of the output. So as this is running, you'll see it goes through and it checks to see if the server is Apache. If it is, it will go through and do the attacks for server status checks. It will go through and see if it can get the host header information like we talked about, and then it will go ahead and check for the private key, and then lastly for the SSH fingerprint. Now at this point, the SSH fingerprint just gets dumped into a file. I do have another Python script which I'll show you that will go through and take the fingerprint, push it up to Shodan, and get any results back for you. Again, lazy, haven't devved it in yet. Probably wouldn't be doing it in Bash as it's in Python now. So let's go ahead and let this run. It might take another couple of minutes here. Does anyone have any questions so far? I'm probably going to run close to the end time here, so if anyone does have questions now is probably a good time as this runs. Yeah.
I'll let you know this is not, I'm violating the not a question rule, but your no host header attack will also work against an improperly configured Nginx instance because there's a default site directive there too. So if you pass no host header to someone who has default site configured on their public facing, you'll probably also have the same success there.
Yeah, that's a good call. I know somebody has looked at a couple of like light HTTPDs as well, or some of the other web servers. I haven't done any testing aside from Apache, only because I figured it was one of the most common. So it was I tried to keep my scans relatively small and limited without deving out a bunch more stuff. But that's a very good call. I'm sure many other web servers may be vulnerable. I know that attack, that documentation in Apache that specifically says it will default to the first is, I think, one of the reasons why that happens. But it's definitely worth checking out. Any other questions? No? Okay. So I'm not going to let this run all the way through. It usually only has another couple minutes to go, but I've got a backup of the output of this. So let's go ahead and take a look at what this script will generate for me when it's done running. All right, so at the end result, I go through and I get any of the URIs that are in the server status page. So right here, we've gone ahead and pulled a fully qualified domain on the ClearNet from this hidden service server status page. It'll also go through and grab the fingerprints and private keys, Apache server status, the Apache header mod. And yeah, so each one of these sites here, and I haven't shown the keys yet, but each one of these sites in this response does leak its public IP or domain information. So this scan, again, it took me probably about 4 or 5 minutes to run, resulted in about probably 12 or 13 hidden services de-anonymized. Now, as far as the keys go for the SSH fingerprint, oops. All right, so in this case, I just run the Python file. It's going to look for a file called keys list. Keys list has all my keys from that scan that I extracted, so I just catted them and grepped them out. And it will go ahead, perfect, awesome, perfect, cool. Yep, marvelous. So, normally, that'll look like this. For the results that are found, there's the IP address to de-anonymize the hidden service. Any of the ones that say found to, that .143 server is the server that's on Shodan that's indexing all of these keys right now. So a lot of these results will return 2 because of that other indexer. So. All right, so we're all hyped up. You want to go do some scanning? Beware. I trimmed a lot of this stuff, and I tried to make it as PC as possible for here. Enough said, and there's some shit out there. Are they safe? For my opinion, I don't fucking know. Who am I to say? There are a lot of attacks, both from a network level and from a configuration level, that can be exploited. So I'm not here to say whether Tor is good or Tor is bad. These are just my findings on the state of hidden services. I'll put the slide deck up on DC562's talks repo. You can find us through dc562.org. But I do have some references here on some really good videos on Tor and hidden services and some slip-ups and some attacks. I also have references here to some of the more important Tor spec papers if you're interested in doing any research. These help me out quite a bit. And then lastly, I help run DC562. It's a local DEF CON group here in LA. If you guys are not part of a DEF CON group in your area, go find one because they are fun and they are awesome. And being with this group has helped me learn and grow immensely. So I just want to say thanks to the group, and that's all I got. Any questions? No? All right. Thank you, guys.